All right, welcome everybody to Inside Modal Sandboxes, how AI agents code at scale. I'm Paul, engineering lead on the Sandboxes team, and I'm joined by Rebecka.
Hi, I'm the product lead for Sandboxes. I don't know if we should get started or give people a few more minutes to join. We're like a little bit past, but
Sure.
maybe we can give people another minute. Maybe for those of you who are here, do you want to share like where you all are calling in from? That would be fun to see where we have people calling in from while we wait for more people to join. Okay, I see New York, LA, Boston, Boulder, Columbus, Arizona, London. Oh, I have to see some Europe, France. I'm in Stockholm. Oh, I see someone else in Stockholm.
And I'm in New York.
But we have people in Canada also. Paul is Canadian.
Yes, I am. We're in Canada. I have not seen chat, so.
We have Vancouver. I think there was some previous mentions of Canada further up as well. Okay, well, it looks like we have people from, all over the world. I see Taipei. It's very cool. We have Rome, New York, Bangalore, Toronto, India, Manchester, Scotland. Okay, we have good representation here.
Cool.
All right, but I think let's get started. So today we're going to walk you through sort of what modal sandboxes are, how they can be used, and specifically focusing on AI coding agents. So the first thing is we're going to talk about what are sandboxes. I'm not sure how familiar you all are with them already. Then we're going to talk about some sort of customers we have that we work with and share a little bit about how they use sandboxes, because we think that's generally helpful to understand how others use them and to get an idea for how they are used in practice. Then Paul is going to give a demo, showing how to build a really cool application with modal sandboxes. And then we're going to talk about common design patterns. And these are basically sort of things that we encounter across our users, different sort of ideas around how to design sandboxed applications. So we're going to share some best practices and some sort of options that you face when building an application on top of sandboxes. And then finally, we'll share some ideas or some advice on how to get started. And then we'll do a Q&A at the end. So we will not be answering questions continuously throughout, but there will be time for questions at the end. But I think let's start. So starting from sort of the basics, what are sandboxes? Well, sandboxes are isolated environments for running untrusted code at scale. And the reason sandboxes have sort of come into being recently is that, as I think most of you probably know, LLMs happen to be pretty good at writing code. And so using LLMs or AI to generate code has sort of become a big thing. But also, as I think most of you probably know, a sort of big unlock here has been having LLMs not just generate code once, but to iterate, meaning you have an LLM generating code and then executing that code in an iterative loop. And that execution has to happen somewhere. And that's where sandboxes come into play. So sandboxes are basically that environment that you can run this LM generated code, which typically is untrusted. You have no idea what it's going to do. You definitely don't want it inside sort of your normal development environment. You want a sandboxed environment, basically. So if sort of the Claude Code era of like this fall was maybe the first sort of step change in productivity for using AI coding tools, I think there's been another recent step change as cloud agents become more common, where you're sort of no longer running this on your laptop, but instead in the cloud. And we're seeing a lot of interest in that. So that's sort of one of the cases that we're going to focus on today. But I think that's the basics on what they are. And I think let's move on to some examples, because I think that makes it sort of a little bit more tangible. So the first one of our customers for sandboxes is Lovable. They build a vibe coding platform. I sort of suspect that most of you probably know what Lovable is, but to just give you a very basic idea, the way it works is you sort of prompt, you start from a prompt, and Lovable helps you build an entire app or website based on that prompt. And once you have done this prompting, you basically end up in this interface, which we have a little screenshot or video of here, where you're sort of chatting back and forth and you're iterating on your application, but you also have a live preview of the app that you're building. And that's the one on the right here, the little game. And you can interact with that preview as you're working on your project. And this is the part that runs inside a sandbox. So the sandbox is sort of the preview environment on a platform like Lovable. And to go in a little bit more specifically on sort of Lovable's architecture, the way that this works for them is they have sort of sandboxes running on Modal. These are started from an image that originally is stored in a container registry outside of Modal, but it gets pulled into the Modal image store regularly whenever it needs to be rebuilt. And then, like, by the time that the sandbox starts, that image gets pulled, meaning it's very, very fast because it's sort of already available within Modal's ecosystem. The sandbox then communicates with Lovable's backend through a tunnel and also communicates directly with the user's browser. The LLM and the coding agent, those run outside of the sandbox. We'll talk more about this later. Another sort of common pattern is to have the agent run inside the sandbox, but in the scenario, in Lovable's scenario, it runs completely outside of the sandbox itself, and it communicates via Lovable's backend through this tunnel. Another thing to point out here is that there's a daemon running inside the sandbox, and that's basically what's used for the communication with the outside world. And this is, again, a common pattern that we'll come back to a little bit later. And Lovable, obviously, they have a lot of different challenges. When it comes to sandboxes, their main challenge is scale. They sort of need to power many, many, many concurrent sessions. They need the ability to scale up very quickly when there's an inflow of traffic. And so the reason that they went for Modal is basically because they needed that scale. They previously used other providers, and they evaluated a bunch of providers as they were considering which one to go for their sandboxes, and ended up choosing Modal for its scalability. And that's basically a common reason that you reach for a sort of sandbox solution like ours. Let's go on to the next one. This is Ramp. And I'll hand over.
So yeah, Ramp is another customer of ours. Similarly doing, using sandboxes to run LLM generated code, but in kind of another pattern that we see, or a different way of using this that we see, which is more like background coding agents. So the way that they've kind of built things is they can actually ask on Slack their agent to build something, and it will then in the background spin up sandboxes on Modal to actually run kind of their version of Claude Code or something like that in the sandbox, generate all those changes and write them back to their, essentially into a Git commit, pull request. So this is another pattern that we've seen be really successful, especially for companies building their own version of this. We've seen there's been interest lately in kind of customizing the agents that you use for your company's code base. And so this is a pattern we've seen across a number of companies. And they chose us for like speed. Startup speed is really important for this type of use case because it's essentially the iteration speed that you can get out of it. Architecturally, the way that this works is that they, essentially they have a running process that manages all the requests coming in, but then when they want to actually run a sandbox session or an inference session, they kind of spin up a sandbox, run an agent loop inside that sandbox, and then write the changes back. And now I'm going to give a quick demo of using...
Time to show you the code.
Yeah. So I'm going to get this kicked off, and it's going to take a few minutes because there's a lot of inference time here, but I'm just going to start with, let's see, what worked before was generate a 3D world inspired by Minecraft. So I'm going to kick this off, and it's going to start this. While that's running, I'll show you what this code is. This is actually an open source example that we publish, so you can actually run this yourself. There's a couple components to this application. There's the piece that runs inside the sandbox, and then there's some other pieces that run outside the sandbox. And actually, I'll show you what that looks like in Modal as well. We have this vibe code app. It's running this create request. So this is deep in an inference right now. It looks like it's found something. Oh, so we get some, this sometimes happens where agents don't always do the right thing. Let's try this. Looks like it's trying to use 3JS. yeah, essentially it's the outer layer is Python. Inside the sandbox, we're running Node.js server that's kind of running this React app that gets generated. So it goes out to Anthropic's APIs, says, here's the prompt, generate something for me. I'm going to switch to a working, this one, it got right. So goes out to the API, gets some code back, kind of injects that into the application. And because it's running in a sandbox, we're not as worried that that code is going to do something bad. It's confined to that sandbox environment. So in this case, I've kind of gone back and forth and asked for the Minecraft-inspired 3D landscape. I allowed rotation. It had a little bug initially. I mean, there's still some bugs here, but pretty good for a few passes.
Cool. And I guess just one thing to mention while we're on the sort of code track is the sort of demo application we were looking at now is written in Python, but Modal also offers JavaScript and Go SDKs for creating your sandboxes. And then inside the sandbox, you can run whatever you like. So you're not limited to any one programming language for the code that runs inside the sandbox. Cool. So moving on to design patterns, this is sort of our attempt to collect our sort of wisdom around what tends to work and not work in terms of designing applications that use sandboxes. And yeah, I think we're going to cover 5 of them. So let's get started. The first one I sort of alluded to earlier. Harrison Chase, who's founder of LangChain, wrote about this on Twitter recently, and the QR code will take you to that entire post, which is a recommended read. It's very good. He wrote about how there's basically two common patterns for how to run agents in combination with sandboxes. You can run them inside or you can run them outside the sandbox. And these approaches, we see both of them quite a lot. They're both valid. We think the first approach of sort of running the agent within the sandbox, that's usually sort of what people grasp for first. It's the easiest. I think that's largely a factor of how applications like Claude Code are designed. They're kind of designed under the assumption that you have the agent running inside the same environment where it's sort of doing stuff and where the code is. So it's usually easiest to get started with. And for a lot of use cases, it works well. There are some security concerns around this because you basically need to you need to put a lot of credentials inside the sandbox, which isn't ideal. But it's generally a good choice for internal coding agents. So Ramp, for example, does this. They run the agent inside the sandbox itself. We have plenty of examples of this on our website. You can find examples for running Claude Code in a Modal Sandbox. We have examples for running open code inside a Modal Sandbox and so on. So there's nothing wrong with this pattern, but there are pros and cons with both. The other pattern, which is to run the agent outside the sandbox, is that you get sort of better separation of concerns. Like, I think if you were to ask like me and Paul, like, which is the long-term viable pattern, I think we both think it's the latter. We think this is sort of where the world is headed, but we'll kind of continue to support both as long as people request that. And there's also, of course, some downsides of this. So one example is that the latency between your server or sort of wherever you run the agent and the sandbox itself starts to matter in a way that matters less if you're running everything inside the sandbox. Usually this is fine, but it adds another concern. And this pattern is generally a good platform if you're building a good choice if you're building a platform like Lovable. Because it basically means that you usually have lots of proprietary logic and code. You have an agent harness that you definitely don't want your users to be able to access. And so it makes sense to run it outside of the sandbox rather than inside, where you would risk having all of that exfiltrated. So these are, one of the first high-level patterns. And yeah, I think we can move on to the next one. I recommend reading that post that was linked. It's very good. Another common pattern is snapshotting. This basically comes from the fact that sandboxes are basically ephemeral. That's kind of the pattern that's emerging in this space. So sandboxes are different from traditional sort of dev box environments where you have one human developer that's doing the work. Sandboxes are usually used for AI coding type workloads where you want the ability to run lots and lots and lots of concurrent sessions. And they're usually short-lived. Like once you have closed your PR, you're not going to reuse that sandbox again, meaning you sort of need the ability to spin up many of them concurrently and quickly, but also kind of spin them down as soon as you're not using them. And so a common pattern for sort of dealing with this, you still sort of want the ability to start up a sandbox and kind of maybe leave for an hour or two and come back to it is to use snapshots. So I think every major sandbox provider at this point provides file system snapshots, which is the most common approach to this. It basically allows you to snapshot the contents of a sandbox file system, shut it down, and then later you can restore from that snapshot, and it's usually very fast. So that's sort of the advantage of starting over and kind of pulling in all of your dependencies and your files again, because then you get much faster startup time. Modal also offers two other types of snapshots. We just released a new feature yesterday called directory snapshots, which I personally think is really cool. It basically allows you to snapshot just one part of a sandbox. So that's a common sort of scenario where you would want or need that, is if you have sort of your own dependencies somewhere, and then you have user dependencies or project dependencies somewhere else inside the sandbox. That means you can snapshot those independently of each other. So you can update your base image without losing the snapshot that you had taken of your project code. And then finally, we have memory snapshots. These also preserve any sort of running processes inside the sandbox. These are in alpha, so they have sort of some constraints. These are all documented on our website. And sort of which one works best depends a lot on your use case. We see sort of all of them being used across our platform. But snapshots are sort of definitely a pattern you will want to look into if you're developing any kind of application that runs on a sandbox.
Yeah, and one cool thing about directory snapshots is that they can be mounted after the sandbox has started, which allows you to kind of have a warm pool of pre-warmed sandboxes and then attach a directory snapshot.
Yeah, and that's actually, I think, the next slide. So perfect segue. So a third pattern is basically to have a sort of sandbox pool where you pre-warm sandboxes. And I want to sort of start by clearing up a common misconception here. There's a lot of sort of talk out there about sort of sandbox startup times and how long it takes to get a sandbox up and running. Usually this takes a lot longer than just starting the sandbox. There's usually a lot of sort of upfront work that needs to happen after you have actually started the sandbox. And the point of doing pre-warming in a pool is basically to do that work before your user is waiting. So we have a link here as well to sort of a pool example on Modal, but the point here is you basically have a pool of sandboxes that are always ready to go and where all of that upfront work has been done already. And it's very application specific, sort of what you can do within the pool and what needs to happen outside. Sometimes you might not know until you have a user that's making a request, sort of which repo is my coding agent going to work on, or which user is it that's going to use this sandbox. And that's where directory snapshots are useful, because that means you can kind of add in more information as you gather it. But typically, a few of the things that would happen in the worm pool is you would start the sandbox. Oftentimes, you would start some sort of server inside the sandbox. You might do a git pull. In some cases, this git pull to kind of fetch the latest changes would need to happen after, sort of outside of the worm pool. So when you claim a sandbox from there, you might need to install some dependencies. But there's basically a bunch of steps that can happen here. But the worm pool allows you to do all of those steps that are sort of anything that's possible to do before your user is waiting, you can do inside the worm pool. So that's also a common pattern, especially for those who are really trying to optimize the sort of perceived end user latency to the max.
Yeah. Another thing that's common with sandboxes is you need to get files in and out of the sandbox. Depending on sort of where in the sandbox lifecycle that's happening and where you need to read the file from, there's a few different patterns that we see that are useful for that. So one is baking a file into the image itself. This is most useful when you have, for example, a server that you want to run in every sandbox. It's kind of part of the image distribution that you're creating to run this on. And in that case, you can use our image builder to sort of bake that local file into the image. We also have volumes, and you can mount a cloud bucket. Those are also useful ways to get a file in if you want it to be reused, but maybe a bit more dynamically attached. We have a file system API, which is useful when you just want to send a file once to a sandbox. Just sending a local file to a particular sandbox. Maybe you have some information about a particular user's prompt or documentation that you want to send into an agent, things like that. You can use our file system API. It's marked as alpha right now. We're very close to releasing that as generally available. And then another way to get files mostly out of a sandbox, although sometimes in, is running a server inside the sandbox. We provide a way to run a server in the sandbox and then get a URL for it that you can access from anywhere on the web, which is also how people embed this applications in their, like, for example, vibe coding applications. But you can also use it just to get files out. And another way to people access these sandboxes is with connection tokens. So this is sort of a security feature. I mentioned you can kind of embed the sandbox server inside an application like a vibe coding app. But if you just do that naively by using tunnel URLs, which is what a lot of sort of demos do, including other providers' demos, you end up exposing yourself to a security flaw because those host names are sent over plain text over the web, over the internet. And so anybody who can access that could kind of access the server that you're running in that sandbox. So we provide connection tokens, which are a way of kind of embedding a secret in that URL that is not sent over plain text, is only sent encrypted, and allows you to authenticate who's actually accessing that sandbox, including when you're embedding it in a vibe coding application. And that brings us to questions.
Already at the end.
Yeah.
I can read some of these questions since I think you can. You're screen sharing, Paul.
Yeah.
Let me see. I'll try not to just pick from the end. Okay, here's one for you, Paul. How do you think about setups which require multiple services? For example, a backend server, database, and front end. Would you recommend all these services exist in one sandbox? If not, how do you think about networking across sandboxes? Thinking something similar to Docker Compose with an isolated network.
Yeah, so this is one that does come up a fair bit when people want to run like a heavyweight development environment in a sandbox. Currently, our approach to that is to run everything in one sandbox. We do have a way of running Docker in sandboxes, although there are a number of edge cases, and it's a little bit finicky by the nature of kind of running all this in a container. We are working on an alternative that will have much more first-class support for Docker Compose. But for the time being, running everything in one sandbox is the way to go there.
Cool. And then we have from Paul, actually, for setting up the sandbox, why would I use snapshots over, let's say, baking it all in an image?
So that comes down to the frequency that you want to kind of use that image with, I guess, is what I would say. Like if you have information that is particular to different users of your application, so maybe you have different users have different repos that they're accessing, you probably wouldn't want to create an image for each of those, just kind of as a matter of ergonomics. It's sort of easier to think about those as volumes. Whereas if you have data that is going to be in every sandbox, then an image makes a lot of sense. So at the end of the day, like a lot of this, the primitives, the underlying kind of things that are happening on our file system do look pretty similar between volumes and images and snapshots. But I think of them as just sort of different semantics around using those, where image is, I think of as less sort of specific to a user. It's just sort of your more the application code or data that your application always needs, as opposed to user data.
I guess we can share a little bit more specifics also on sort of how others typically do this. So on like a vibe coding platform, the typical setup would be that you have snapshots that are keyed by the end user. So when the same end user comes back, you want to restore from that snapshot associated with that user and their particular project, actually, probably rather than user. meaning it probably doesn't make sense for you to build one image for every one of your users or every one of your users' projects. That's very many. But it makes sense to have something that's basically keyed by the user or user's project. Ramp, they write about this in their blog post, which is a very good one, by the way, so you should read that one. They use snapshots a little bit differently. They basically build snapshots every 30 minutes from their repos. So they have a bunch of repos that they use Inspect on. And for each of those, they rebuild a new, it is basically an image. When you take a snapshot, the resulting artifact is an image, but they do it using the snapshots mechanism. And this is to minimize the amount of work that needs to happen when you start the sandbox. So there needs to also be a git pull that basically pulls the latest changes into the sandbox, everything that has happened since that thing that can be at most the last snapshot, which can be at most 30 minutes old. But by doing it kind of frequently, that means there's not too much work to do there. There's not too much to pull, and that kind of helps keep startup latency lower. So there it's basically keyed by the repository and a timestamp. But it varies sort of exactly how people use these. Cool. Next question. What are your security concerns with agents running inside the sandbox? If, for example, if LLM provider credentials are injected via proxy?
So this is one that kind of, I'll go back to this sort of architecture slide. So this comes up more in this case where you're running an agent inside the sandbox, which is, I guess, it has some fundamental problems for the same reason that running Claude code anywhere has fundamental problems, in that the code that the agent is running isn't necessarily isolated from the environment that it's running in. Anthropic has been working hard, I think, on kind of creating a layer of isolation so that the code run by the sandbox is sort of contained. But in general, with these kind of coding agent harnesses, and this is a problem whether you're running it locally or in a sandbox, it's essentially the same thing, is that it has access to the API tokens that you're using. So one approach to this is to go through a proxy, which I think the question kind of alluded to. Like, you could have the agent call out to a proxy with a temporary credential. That proxy could replace that temporary credential with the real thing. And that way, if the agent had some bad instructions, bad prompt, it couldn't actually exfiltrate that. But this is generally where, like, if this is a big concern for you, I think that the approach of sort of having the agent harness run outside of the sandbox is really the approach I'd recommend. I think it's like the kind of the long-term direction that things are going to go. And I think right now it's just sort of, because these agents are in their infancy, we haven't sort of seen that separation take place yet.
Cool. Another question. What makes Modal so much faster than, say, I think this EC2?
Yeah, so with EC2, you're like waiting on them to provision the VM, and it's, I think it's traditionally not something that they've expected you to do from within an application. Like, you're expected to start EC2 instances from infrastructure code, and infrastructure code is generally not like waiting on a human. It doesn't need to be fast. You're expected to be running, this EC2 instance potentially for months or years even. Like, these are kind of long running instances where whether they can start up in 2 seconds or 45 seconds is not really a big difference to the users of EC2. With us, what you're getting is we provision with a lot of overhead so that we can very quickly sort of just have a fast scheduler decide where to run your code, where to run your sandbox, where there's capacity for the memory that you request and the CPU you request. And then we can, we've optimized the system to make that process very fast, because our customers are calling this code from application code. And so, we recognize that it needs to be fast. So I think it's partly priorities, partly sort of the technical infrastructure of how they do things.
Cool. Do you have any examples of what kind of development directory snapshots enables that was not possible with the old tools? And I can take this one. I think if we go back to the lovable architecture slide, I can try to make it my answer specific. So let's say this is your setup. You're building a vibe coding platform. A common scenario here would be you have this daemon that's running inside the sandbox. So this is basically Lovable's logic in this case. You want to make some updates to this. You want it to work differently. You're changing something about how this works. If you have previously taken a bunch of entire file system snapshots of every single user project that has ever been run on the platform, as soon as you're making this change, you have to throw all of them away. None of them are up to date anymore. And so now suddenly, instead of restoring from these snapshots when these users come back, you're going to have to start from scratch and build their entire environment and do all of this sort of work that you are hoping to avoid, and pulling in their user code from some Git storage and so on. And you sort of miss out on all the advantages of snapshots when you want to make that kind of change. And so with directory snapshots, you basically don't have to. So with directory snapshots, you can snapshot the user code separately from your own dependencies. And that way you can kind of replace your base image without losing the snapshot advantages that you have from snapshotting specific user projects. I hope that made sense. Is there a way to use eBPF to inject credentials at the network level?
We don't provide that yet. We've been thinking about some of those things. A lot of the trickiness with using something like eBPF for this is that, assuming that we would have to kind of do that on the host system above the VM itself, is like when web traffic leaves one of these sandboxes, it's already encrypted, so we can't see it. So there are some providers who will kind of man in the middle of that connection and do secret replacement and things like that. There's a lot of philosophical debate internally of whether that's a valid thing to do, honestly. I don't like the idea of kind of like sitting in the middle of someone's connection and decrypting it and then re-encrypting it. So we're looking at alternatives to that approach for connection, authentication token injection and things like that.
How do you reduce excess cost with sandboxes? How do you generally manage the scaling of worm pools? I can take this one. Sure. So for cost, the way that this works for sandboxes, you get charged for CPU and memory consumption. When you create a sandbox on Modal, you can pick an amount of CPU and memory that you request. So this should basically represent a best guess for what you think your sandbox will use on average. However, our experience is that sandboxes generally are very, very bursty in their CPU and memory consumption. So you don't usually need the same amount of CPU and memory throughout the entire lifetime. And on Modal, you basically pay only for what you use. So the way to kind of reduce costs on sandboxes is to basically go for a provider like us. Many other providers will basically require you to provision an amount of CPU and memory that's like the max your sandbox can consume, and then you pay for that the entire lifetime of the sandbox. With Modal, you don't. You can kind of request less and burst above whatever you requested. That's one, but then also tuning your request. That's sort of the most common way to control your sandbox cost, is to think about like what request you actually need. So the request does not need to represent your max expected CPU or memory usage. It needs to represent like the expected or average usage, especially if you're running across many sandboxes. And you get charged for the maximum of the requested amount and the actual amount. And you get charged by the second, but I think this is the case across all providers that I know of. So everyone charges by the second for CPU and memory usage. The difference is on Modal and certain other providers, you sort of can burst above the request and only pay for what you use, whereas many others require you to kind of decide upfront how much memory and CPU you're going to have access to, and then you pay for all of that. Does the Modal Sandbox region selection guarantee the chosen region? Additionally, the region docs say all function inputs and outputs go through Modal's control plane in US East 1. Is this also true for sandboxes?
So region pinning should guarantee it. If you're not seeing that, then that's a bug. But yeah, if that's it's basically what will happen is if there's not availability in that region and you select a region, you won't get scheduled. So We generally try to steer people away from region pinning unless there's like a compliance reason. And then the second part of the question, yes, does everything travel through? So for sandboxes, for tunnels, it does not. So when you create a sandbox and then set up a tunnel to it, that tunnel connects directly to that sandbox. And so if it's a sandbox that's scheduled in EU, that data is never leaving EU. Similarly, like if it's US, unless it's traveling, between the client and the server outside of that region.
And I think just to clarify, the quote that was in here from the docs, it basically says in the quote, like all function inputs and outputs. So this refers to modal functions, which are separate from modal sandboxes. So this applies to functions specifically and not sandboxes. How does modal snapshot pricing work? I can take this one. It's a simple answer. We do not charge for snapshots themselves. We will at some point in the future probably charge for storage, but I don't think that's going to be a substantial cost for most users. So I wouldn't worry about it. It's basically a feature that we hope makes Modal more valuable, but we don't intend to charge for snapshots themselves.
I think it'll be sort of roughly in line with like the underlying cloud storage cost of that.
Yep, exactly. Oh, and then we have follow-up. Yeah, I didn't cover the worm pool part. So does Modal maintain any pre-wormed pools, or is the only way to have wormed instances equal to a user having to use the wormed pool feature? It's complicated. we don't have any sort of built-in worm pool functionality, although it's something we're developing, so we will soon. However, we do maintain a lot of capacity that we can schedule sandboxes onto, which is how we are able to schedule sandboxes really fast anyway. So no, in the official sense, yes, sort of in practice, but it's not yet a sandbox, the thing that we maintain. It's capacity that we can schedule sandboxes onto. All right, I'm going to scroll up because I think there were a few questions here that we did not cover yet. Does the snapshot runtime itself protect against accessing MCP services in an unauthorized manner, e.g. download DB data, delete Git repo? If not, then why run in a sandbox?
Yeah, so sandbox is not protecting from like calls being made outside of the sandbox, unless you can restrict network egress, but assuming you don't do that, like the sandbox can call things outside. So if there's a MCP service that you're exposing to it that can do bad things outside of the sandbox, then the sandbox itself doesn't protect you from that unless you just cut off access to it. And that again goes, way it goes to like that connection once it leaves the sandbox is encrypted and we don't see it. So we don't try to prevent you from doing bad things over an encrypted connection. Getting back to like the core reason of the sandbox is like the sandbox provides that isolated environment that you can kind of anything you don't put into the sandbox in terms of like user data and things like that, it's not exposed to. So instead of running, say, code on a user's machine where it could access all kinds of files and things like that, running in a sandbox is, it's an isolated environment. So yeah, hopefully that answers the question.
Can you all elaborate on why agents outside the sandbox is the emerging pattern? Oh, look at this. Now, you still can't see it. I'm going to continue reading the question because
sure.
All right. Yeah. For agents to utilize the code base as a source of truth, wouldn't the agent need to be running inside?
So I see it as two different things. So there's the agent itself sees the code base through tool calls generally. So, and this is sort of an emergent pattern. At one point, there was the RAG era where the agent would get a bunch of context in advance from the code base, kind of pre-populated into it. These days, Cloud Code kind of spearheaded this. Like the tool calls are really the way that accesses it. So the way that you can make this work where the agent can see the code, even if the agent is sort of running independently, is that the tool calls cross from the agent world into the sandbox and are handled inside the sandbox. So if you have, maybe the agent wants to run a grep over the code base to sort of find a bunch of relevant files, what it's really doing is making a tool call into the sandbox. The grep runs inside that sandbox. You also put the whole code base in that sandbox, so that's why it's able to see it. And then you're able to get the results back from that tool call, feed that back into the agent, and then you call out to the LLM from the agent. But again, that piece of the agent is running outside of a sandbox, or maybe it's in a different sandbox, but it's not the same sandbox that you're running those actual tool calls in. And that just kind of creates that separation.
Cool. I have a perfect question for you coming up, Paul. Is support for domain whitelisting for network egress, not just CIDR ranges, on the roadmap? If so, when?
It is, yes. And this is another one that kind of gets to that tricky point of like, we don't want to read traffic leaving a sandbox. And so for folks familiar with like networking in general, what we can see when a packet leaves a sandbox is its IP. We can't see the domain it's headed towards. So there's a few different tricks or different ways we could kind of do this. We're still thinking through the best one, but likely what we'll do is run a proxy outside of the sandbox that doesn't allow us to see the traffic, but does allow us to verify that it's at least going to an IP that is valid for the domain that it's destined for. But yeah, it's something we're very actively thinking about. I would say we don't have an ETA yet on that.
Great. Can you see the questions now, Paul, by the way?
No, I just see
I
my
think you
screen.
can stop screen sharing.
So I'll stop screen sharing, sure.
But I'll continue reading them. Can we talk a bit more about the difference between functions and sandboxes? You can mount a volume and call subprocess.popen to execute a process from a function. What's the difference between this and calling sandbox.exec?
Yeah, so it's actually valid to do subprocess popen in a modal function, and you can, like, there have been cases where we actually do recommend people use functions like sandboxes. There are a few precautions that you want to take in that case. So you want to make sure that each of those functions is not handling different requests concurrently or even subsequently, because you kind of want to not break that isolation. So you can use max inputs equals 1 for that. Also, functions by default receive modal credentials so that they can make API calls to modal. You also want to disable that. We have a parameter that you can use for that when you decorate the function. Aside from that, it really comes down to whether there are features of functions that you want to use. Like, this is actually ends up being a really nice way to just sort of create a warm pool, is to use modal functions, even if you're running arbitrary commands, as long as you kind of take those precautions. The other thing is you need to be calling this, if it's a function, you need to be calling it from, or at least declaring it in Python. There's still a Python sort of layer that runs in that container. With sandboxes, you kind of just get a raw container. So both are valid, as long as you make sure you're careful with those max inputs and not passing the modal credentials. But it really just matters. It's just a matter of which form factor you like better.
Great. Is there an option to increase a sandbox timeout after it has been started?
We don't have this at the moment. What we do have is a concept of an idle timeout, where if you don't call exec for a while or don't have open connections to a sandbox, we'll terminate it after a certain amount of time. So you could kind of hopefully get the effect that you want with this. As we think about first-class warm pools, this is something that I think is going to come up again. So we'll hopefully have a better answer for that.
And we've got a question that I'm not sure either of us know the answer to. If there's any examples of the outside pattern in the examples repo, do you know off the top of your head, Paul?
So the the modal vibe, the demo that I showed is sort of an example of this. I think it's a little bit, yeah, I mean, I guess there is some sort of, the one difference is that it kind of waits for the user interaction. It doesn't do multiple steps autonomously on its own, but it essentially does implement that pattern. What really happens there is it's sort of, it's taking the prompt. All of this runs in like a modal function that's not a sandbox. But when it receives that prompt, it kind of goes out to the LLM, gets some stuff generated, opens the sandbox, sends it to the sandbox, and as you continue to iterate, it kind of goes back to the LLM and then into the sandbox. But that loop is not running in the sandbox. It's running in a modal function.
I think we're soon out of questions, but here's an interesting one about sort of compute SDK benchmarks. Can you see it? No, I'll read it anyway.
Yes.
Okay, I'll read it anyway for everyone else's sake. I have been benching various permutations since that compute SDK post a few days ago, the one that E2B Daytona architectures shows spinning up in 0.2 to 3 seconds. Modal seems to constantly pull 1.2 to 2 seconds. My question is, does Modal not have worm pools for some common set of common/default parameter images? E2B and Daytona have sort of a smaller space of image configs, which lets them have an advantage when using worm pools. When I worm Modal Sandboxes, I can get 0.3 times and less on concurrent hits once gRPC kicks in.
Yeah, this is actually those saw those benchmarks as well, and they kicked off this discussion internally of like, should we kind of be doing this as well? And I think one of the things that's come up is like when we do this at scale for enterprise customers, like they don't want the base image that this benchmark actually tests. So I think that this benchmark is great for what somebody just sort of experimenting with a sandbox and running a few exec calls is doing, but not really somebody who's deployed a sandbox in production where it needs to load an image and probably has some startup tasks and things like that. So for those use cases, what we really see is people building worm pools around their own images. And one of the things that's been tricky about like building first class support for worm pools is that what you want to do in a worm pool is different from use case to use case. So sometimes it's a matter of just you want the image to be loaded, but sometimes there's a process you want to run. Sometimes there's some pre-work you want to do. So the approach to sort of allow the customer to build the worm pool has been sort of the maximally flexible option here. And I do think, so it's awesome that E2B and Daytona have had like really great cold starts on these metrics. But I think, for what we're optimizing for, it's we think that this is sort of less of the big issue.
Cool. There was a follow-up to the idle timeouts question. The sandbox isn't idle if a TCP connection is open. So in the lovable case where a daemon with the daemon, a TCP connection would be open. How do they handle the timeout and termination of sandboxes? I can say, like, in general, this type of customer will usually handle they will have their own logic outside of the sandbox for sort of pinging it regularly, checking if it's idle, and determining sort of from outside whether it's time to shut down the sandbox. So the common pattern is still.
I was going to say, you can also do it from inside the sandbox too. So like if you have, a Vite server or something like that, you could have that just have some hook to receive a ping from the client, and then if it's still active or if you just don't have any input for a while, you can shut down the process. And once you shut down the process, that frees up the sandbox.
But basically, the recommended pattern here is pick a long timeout and then take control of shutting down the sandbox using custom logic if you're operating at this scale and with this sort of need of granular control. Any plans for full TypeScript SDK support? If I remember correctly, the functions and sandbox operations require Python. Sandboxes should be fully supported in TypeScript already. Let us know if not. There might be sort of some minor stuff missing, but I think we're very close to full feature parity on sandbox operations. Functions is a different story. That's likely to not be supported in the TypeScript SDKs. The Go and TypeScript SDKs are generally mostly used by sandbox users. So that makes sort of worm pools a little bit tricky, but as we've sort of alluded to already, we have built-in support coming up for that. In general, you usually don't need functions in order to use sandboxes on Modal. So you can usually be fine without.
Yeah, I think, for some historical context, like Modal, the first interface to Modal was sort of decorating Python functions and sort of getting this really magical deployment experience. And then for sandboxes, yeah, we treat sandboxes as like it should have support in Go and TypeScript at the same level as Python. I think historically there's been some differences, but going forward, the SDK team's been pretty clear that we need to provide support for all languages equally.
Cool. Can we make sandbox communication pub sub using queues, Kafka, instead of WebSockets?
Yeah, so you can make outgoing connections from a sandbox. So as long as you can kind of provide some sort of ideally short-lived authentication token or credential, you could totally have them either in or outbound. When it comes to inbound connections, ideally do you use something that can support TLS, but we also have unencrypted tunnels. They're just not as, they go through a relay, so it's not as direct, but yeah, you can use any protocol that you can send over TCP.
Cool. Is it possible to have an agent in a sandbox that wants to run scary commands like curl to be able to run them in another more isolated sandbox? So sandboxes calling sandboxes with different kind of isolation.
Yeah, and I think this is a good pattern. This kind of gets back to sort of like having a separate agent and code execution. So you could spin up a sandbox that has modal credentials to spin up on its own sandbox. I think that's a good way to do it. You could also use a modal function for that first one, because then you get those modal credentials for free. So yeah, it's a matter of ergonomics.
But this is generally a pattern we are thinking a lot about and are sort of thinking about how to best support. So we think this makes a lot of sense. Yeah. What's the best practice around receiving logs from the sandbox? We want to store them so we can later inspect the telemetry from sandbox sessions.
Yeah, so we can do OTel export and Datadog export. So that's the most common way to do it. There are also just logs available on the dashboard for like manual inspection, but for programmatic export, I think OTel and Datadog are the primary ways we do that.
Cool. I think we're running out of questions, and the last one we got is the perfect segue, I think, to the last thing we have to mention. Modal credits. Yes, there will be modal credits for everyone who's joined today. So if this whole session has made you excited about trying out Modal, what you can do is you can go to modal.com, you can sign up for an account. Everyone by default gets $30 of credits every month. But everyone who's attending this webinar will also get $250 in credits so that you can experiment even more and use sandboxes. You'll get those credits in a follow-up email after this. And basically the recommended way to get started is to start by cloning one of our examples. The open code one I think is really cool. It's one of our most recent ones. But there's plenty listed on our website. There's plenty, if you go to our docs, there's like a list of examples, and there's even more on GitHub. So you can almost certainly find an example that's relevant to what you're trying to do. So that's usually the recommended starting point. Pick one of the examples, clone it, run it, and start modifying it. And I think that's it. We've basically covered everything that we intended to cover. If you have any more questions, you can reach out to us in our community Slack. We generally monitor that and answer questions. There's I forget what it's called, but there's a specific channel for coding, for sandboxes or for coding agents. I can't remember.
I think it's code sandboxes.
Oh, code sandboxes.
Code sandboxes, yeah.
So you can get in touch with us there. And yeah, happy coding. Hope this was helpful. Thanks, everyone.
Thank you.